Hello students, this is Dr. Asifulla, working as Associate Professor and Head in the Department of Mathematics in Vijaya Vittala Institute of Technology, which comes under Bangalore Road, Bangalore. Let us discuss today's topic, limit of a function using L'Hospital's rule. Now let us take one example. Limit as x is tending to 0, log tan ax to the base tan bx. So this is the function here. This is the function for which we need to find the limit as x is tending to 0. The very first step is consider k as the given function along with the limit. Now we will bring this function to the form 0 by 0 or infinity by infinity, so that we can apply LH rule and simplify further. So we can write this function as log tan ax divided by log tan bx. By taking common base e. By taking common base e, we can write log tan ax to the base tan bx as log tan ax to the base e divided by log tan bx to the base e. So with the help of common base e, we can rewrite any function which will be of this form. We can split. Now let us substitute the limit and check whether it is 0 by 0 or infinity by infinity or something else. We have put 0 in the place of x. That means we have applied the limit wherever x is there. You can see we have put 0 in the place of x. And you can observe tan 0 is 0. The value of tan 0 is 0. In the denominator here also we have tan 0 is 0. So what we got, log 0 divided by log 0 we got. Yeah, very first thing we have written this a into 0 as 0. More simplification has been done here. And b into 0 has been taken as 0 first. Now tan 0 value is 0. So tan 0 has been taken as 0. And tan 0 here also is taken as 0. Now the value of log 0, you need to remember the value of log 0 is minus infinity. The value of log 0 is minus infinity. Divided by log 0 is minus infinity. So it is of the form infinity by infinity, which is indeterminate form. Which is indeterminate form. So we can apply LH rule, that is L'Hospital's rule, to the equation number 1. Let us apply LH rule now. Applying LH rule to equation 1. So k is equal to limit as x is tending to 0. And we differentiate numerator separately. Differentiation of log is 1 divided by tan ax first. That is differentiation of log tan ax is 1 by tan ax. Then we differentiate tan ax once again. The differentiation of tan ax will be secant square ax. Again, inside tan we have ax, which is again some function of x. We need to differentiate this again here using the chain rule. When we differentiate ax, we keep a as it is, and the differentiation of x will be 1, which we have not written here. So this is the differentiation of the numerator part. Similarly, let us separately differentiate the denominator as per the LH rule. It says log of tan bx. The differentiation of log of tan bx becomes first 1 divided by tan bx. Then again, we differentiate this inside function tan bx using the chain rule. Differentiation of tan is secant square. Then bx as it is inside. Now let us differentiate bx again. Differentiation of bx will be b, and the differentiation of x is 1. Now let us further simplify these things. We can write these as in the arranged form: a secant square ax divided by tan ax, which we have written here. And this also can be written in the simplified form by arranging the terms in this way. Now let us take this denominator to the reciprocal. It means to the numerator we take, it becomes the reciprocal, which we have done here. We have taken it to the reciprocal. I have taken the same step from the previous slide here. Now let us write the constant outside the limit. A divided by b is a constant which is independent of x, which we can write outside the limit. Now inside the limit, let us rearrange the terms. Secant square ax we will write first, then into 1 by tan ax we will write now. 1 by tan ax we will write now. We are just rearranging the terms. Yes, we have written. So this mixed thing has been separated like this. Now here also we will separate these two. Let us see how we do. We have written the numerator separately and the denominator separately. 1 divided by secant square bx we have written here. Why we are doing so? Intentionally we are doing so that further simplification can be done. Let us see what all changes we can do now. A by b limit as x is tending to 0 we have taken as it is. We can write secant square ax as 1 divided by cos square ax. We can write this, and 1 divided by tan ax can be written as cos ax by sin ax, because 1 by tan ax is cot ax, and cot ax can be written as cos ax by sin ax. We can write like this. Then tan bx can be written as this. Tan bx is in the numerator, so we can write this as just sin bx by cos bx. And 1 divided by secant square bx is nothing but cos square bx. We all know. Yes, we have taken as. See, I said why we have written like this. Intentionally, we have written like this. For what reason? See, in the next step, few things are getting cancelled. Cos ax with 1 cos ax gets cancelled. And cos bx with 1 cos bx will get cancelled. Now let us write what remains. In the numerator, what remains is sin bx into cos bx, which we have written in the numerator here. In the denominator, what remains? Let us see. Sin ax into cos ax remains after cancellation. Let us write that here. Yes, we have written. See, we have simplified such a complicated thing to this level by just manipulating the things. We did not apply any LH rule here. We have just manipulated the things to bring it to the simple level. But still we can simplify this. Still we can simplify this further. You all know 2 sin theta into cos theta. 2 sin theta into cos theta is sin 2 theta. So this is of the form. If you write 2 here and here, this numerator looks like 2 sin theta into cos theta. The denominator also looks like 2 sin theta into cos theta. In the place of theta here, we have bx and bx here. In the denominator, in the place of theta, we have ax and ax here. Now let us write using the identity. Yeah, first we have multiplied and divided by 2 to bring it to the form 2 sin theta into cos theta. Here as well in the denominator. Yes, as I said, we have an identity to write like this, sin 2 theta, and here as well in the denominator, sin 2 theta. Theta, in the place of theta we have taken ax here, and in the place of theta we have taken bx here. See, using this identity, we have further simplified to this extent. Now let us apply the limit and check whether we will get the finite answer or not. Yes, we have applied the limit x as tending to 0. 2b into 0 is 0, which we have written here, and 2a into 0 is 0, which we have written here. And we all know the value of sin 0 is 0. Here also sin 0 is 0. So finally, we will get the answer as 0 by 0, which is an indeterminate form, which is an indeterminate form, which is of the form 0 by 0. So what does it mean? We need to apply LH rule now because it is 0 by 0 form. Now we say applying LH rule to equation number 2, to this equation we need to apply LH rule because this equation is giving 0 by 0 form. Now let us apply LH rule now. Everything we have written as it is still here. You can observe we have written as it is, and we have differentiated sin to bx. Differentiation of sin, we all know it is cos. Differentiation of sin is cos. Inside function we need to keep as it is here. inside cos. So differentiation of sin 2bx is cos 2bx into differentiation of 2bx has to happen by using the chain rule. When you go to differentiate 2bx, 2b will be kept as it is as a constant, and the differentiation of x is 1, which we have not shown here. Similarly, let us differentiate the denominator. Differentiation of sin 2ax is cos 2ax. Differentiation of sin 2ax is cos 2ax into differentiation of 2ax using the chain rule, which gives just a 2a. We have written this. Now let us further simplify by applying the limit. If you apply the limit here and here in the places of x, which we have applied here, we all know 2b into 0 is 0 and 2a into 0 is 0. And also we know cos 0 is 1. In the denominator as well, cos 0 is 1. Yes, we have written cos 0 value is 1 and cos 0 value is 1. Now you can observe what all changes will happen here. 2 gets cancelled with this 2 and b gets cancelled with this b. A gets cancelled with this a here. So finally what remains is the answer as 1. The answer will be 1 after cancellation. Final answer is 1. So by applying the LH rule, finally we got the value of the limit of the given function as 1. So this completes our problem.